We are picking up for our final day in lesson 3.5, and we are ready for example C on the back. Okay. If you recall from what we were doing yesterday, we were trying to find all real and complex zeros. Okay. On each of these, there's an equation and a graph given. The graph gives us our starting point, and then we have to use the equation from there on out. Okay. With that in mind, what information does the graph tell us on C?
W.
-2 and 2.
Okay. My graph crosses the x-axis at -2 and 2, yes? So that means we know right off the bat that we have zeros at x equals -2 and 2. So before we, just to start the problem, there are 2 of my answers, right? How many total answers am I going to be looking for on this one? 4, because it's an x to the 4th, right? Because we're finding all possible answers, real and complex, so real and imaginary, we know there's going to be 2 more. Now, I was kind of reminding you guys yesterday that if you have zeros of 2 and -2, these can be written as factors, and the factors they would represent would be x plus 2 and x minus 2, yes? Okay. What's the main difference between this problem and the other 2 we did? Instead of having 1 starting point, we have 2 starting points. Okay, well, what that means, we usually use our starting point and use synthetic division to work on factoring it down, yes? We're going to do synthetic division twice. Now, stick with me. Okay, don't try and jump ahead. What synthetic division do you want to do first? You want to use -2 or 2? I heard 2 different answers already. And here's, in all honesty, doesn't matter. No. Okay, so if I put 2 here, what goes in the row next to this?
1,
0.
1, 0.
-3.
0. 0.
Because you have to
-4.
So x cubed with x. So we have to solve it for that 0, so we have a placeholder.
Okay.
Okay.
Is this coming back to us? Okay, and I'll re-explain, but good explanation here. We have x to the 4th, which was 1. What should come after an x to the 4th term? An x to the 3rd term. We don't have 1, so we use a 0 placeholder. What should come after x to the 3rd? X to the squared term. So we put the -3. Then we should have an x to the 1st. We don't have 1, so there's our 0 placeholder, and then -4. Okay? So, okay, leave a line for work. Draw your line. We're becoming confident with, start to say scientific notation. Wow. Synthetic division. Drop the 1, and then multiply. 2 times 1 is 2. Add 0 plus 2 is 2. Multiply. 2 times 2 is 4. Add -3 plus 4? 1. Multiply. 2 times 1 is 2. Add 0 plus 2 is 2. And then multiply. 2 times 2 is 4. -4 plus 4 is 0. Now, this is good news, yes? We got a remainder of 0, which means 2 works. We expected 2 to work. It's on the graph. There was never any question whether it would work, but there's our confirmation. Now, okay, here's the catch. What are we going to use synthetic division with now? No, not yet. We have another 0. We did 2. Now we're going to use synthetic division again, but with -2. Now, here's the difference. I'm not going to go back to my original row of numbers. I'm going to use the answer for my previous synthetic division. Okay, and that's why I said don't get too far ahead of me, because if you got ahead of me, you tried to go from the beginning again. But we need the result of using this new one. So, Because, okay, so we're using, it's not that you couldn't go back and use the original one. But if we go back and use the original one, we're going to need the answer we get down here to find our other two imaginary answers. Okay?
Okay.
And it'll make more sense. We didn't have it, I know you missed yesterday, but we didn't have it yesterday where we had to do synthetic division twice. Okay? And if you look back at the ones we did yesterday, we did the synthetic division, and then we took that answer and we did quadratic formula or whatever we needed to solve it.
But frankly, I feel like looking at spell, it'll probably make more sense when I look at the YouTube videos. So.
That I would suggest that. Okay. Now, so we're going to use the 1, 2, 1, 2 to do our synthetic division here. Okay. Because we need the result of this. So we're going to drop the 1, multiply. Negative 2 times 1 is negative 2. Now we're going to add. 2 plus negative 2 is 0. We're going to multiply. Negative 2 times 0 is 0. We're going to add. 1 plus 0 is 1. We're going to multiply. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. Remainder of 0 as expected. And this tells us that negative 2 works. Now, it doesn't matter whether you did 2 then negative 2 or negative 2 then 2. We all will have the same thing right here. Okay? And my question is, what does that 101 represent? I'm going to have to put it off to the side because I ran out of space. But what does that 101 represent? X squared plus 1? Are you with them? Because if we go back to the beginning, this original one was x to the 4th. We divided out, so it's x to the 3rd. When you divide out again, now you're at x squared, right? So this represents x squared plus 1 as our other factor. Okay? So let's look at what factors we have. We already had the factors of x plus 2 and x minus 2. And what's the other factor we just came up with? X squared plus 1. Okay. The x squared plus 1 is the one we need to worry about, right? We know what's going to happen with the x plus 2 and x minus 2. We already have those answers. Okay, so we already know when we do x plus 2, we have one of our answers of x equals negative 2. We already know when we set x minus 2 equal to 0, we have an answer of x equals 2. What we need to find out now is what happens when you set x squared plus 1 equal to 0. Partially. And here's the deal. What have we done to solve the last couple of problems we did? We actually had to do the quadratic formula, yes? Because we had 3 terms, we had to solve it. Do we have to do quadratic formula here? No. Solve with me. If it's x squared plus 1, you need to subtract 1. So then I have x squared equals negative 1. How do I solve? Take the square root. What is the square root of negative 1? I. What is the square root of negative 1 in an equation situation? Plus or minus I. That's why I said partially right to I. Not disagreeing. However, I'm not going to give you full credit. Salvus isn't going to count it right. You know, picky. Okay, so we have what in the way of answers? Negative 2, positive 2, and plus or minus I, positive I, negative I, as all of our answers. How many answers did I end up with? 4. How many was I supposed to end up with?
4.
It was x to the 4th. So there's going to be 4 total solutions. -2, +2,
Yeah.
and then I wrote this one as plus or minus. Which technically I could have written this as plus or minus 2. I just didn't.
I don't understand this. I'm not gonna lie. Like, I don't understand any of it.
It's a process, that is for sure. I mean, the big thing is using the graph to get the numbers you need and using the synthetic division. Okay. When you get done, like yesterday, we used quadratic formula. This one that we happen to do today didn't need quadratic formula. Okay, and it'll just always depend on the scenario. Okay. What I can do if you want, let me go ahead and let's go through these last two, which is something somewhat different. And if I need to, I can go back and talk through some of these and answer questions, unless there's a specific question you have right now, but it sounds more general. So, okay. The bottom section is solving. Okay. What is the solution of the equation? In this bottom section, I'm not really going to teach anything new, but it's big stuff. It's putting old stuff back together. It's, not saying it's easy by any means, but it's stuff you have seen. Okay. As we look at A, thoughts on how to solve that equation? Okay.
Are we going to need to get it set equal to 0? So we need to like move one side over.
I would encourage you to make it equal 0. And in the process of making it equal to 0, we are going to find that the x cubes cancel. But at that point, you're going to have an x squared, an x, and a number term. And those equations we usually work with when they are equal to 0. Which way do you guys want me to take these terms? She says take these 3 on the left to the right. Are you guys okay with that? And I'll say it doesn't matter either way. Okay. I kind of get there's only 3 terms on the left, so taking 3 terms to the right is maybe a smidge easier than taking 4 terms to the left. Okay. So if we're going to do that, that means I'm going to be, let's see, I'm going to subtract x cubed. I'm going to add 7x, and I'm going to subtract 6, yes? So let me write these in. I said I'm going to subtract x cubed, add 7x, and subtract 6. Okay, so do the cleanup with me. On the left, everything cancels. Officially, you have 0 equals. On the right, x cubed minus x cubed. Just so happens to cancel, not going to complain there. And then what? You have a 5x squared that doesn't have any like terms. Negative 2x is going to go with plus 7x, which is plus 5x. And then minus 24 minus 6, minus 30. Okay. Okay, guys. Thoughts? Okay.
Would it change anything with like the big equal 0?
No, I will end up actually putting equal 0 on the right side. I'll just flip it as I go. Now, I will say if you moved everything to the left originally, then all my signs are opposite. And that's fine. Okay. Now, it was noticed that everything is divisible by 5, yes? Now, I'm actually going to use the idea of factoring the 5 out, but you could divide by 5. Same idea, right? It's a matter of where you write the 5. So if I factor the 5 out and put it out front, what remains? 5x squared divided by 5 is x squared. 5x divided by 5 plus x minus 30 divided by 5 minus 6. And all of that equation is equal to 0. Now what? Factor? Does that piece in the parentheses look familiar, like something we've done a lot of?
Mhm.
Yeah. X squared plus x minus 6 looks like it should factor into 2 parentheses. So I'm going to put my 5 out front. And then I'm set up to do 2 parentheses, yes. What do we know? X squared breaks into x and x. What do you need in the way of numbers? Numbers that multiply to be -6 and add to be invisible 1.
3 and 2.
Okay. It's a combination of 3 and 2, specifically +3, -2. Or if you prefer, -2, +3. Now what's our official move? Okay, Sage factor equals 0. Now, the 5. Do I have to set the 5 equal to 0?
I mean, technically no.
Here's the deal. 5 equals 0. I just created a false statement there, yes? Does anything come of that? No. Now, what if that had been 5x? Then it matters, right? If there's an x in there, you have to do it. If it's just a variable or a number like that, we can drop that out, okay? So the 2 pieces that matter, x plus 3 equals 0 and x minus 2 equals 0. If it's x plus 3, I'm going to subtract 3. If it's x minus 2, I'm going to add 2. What do we get for answers? Okay. X equals -3 and +2. Speak around factoring. You know how to do that stuff. Get those like terms. And then do your solving. Questions on that one? Okay. Excuse me. Well then, shall we look at B? X to the 4th plus 2x squared equals -x cubed minus 2x. Thoughts?
Should bring the right.
Okay. Make your equation equal to 0. See what happens? I agree. So if we're, in Roger's terms, going to bring the right over to the left, which it works. And that to me says, okay, then I can get rid of my negatives. So I'm going to be adding x cubed and adding 2x over. So we're going to add x cubed and add 2x on the left. Okay, well, what happens on the left? Is anything combined? No like terms. So when we write this out, we're going to have what?
Plus x squared plus 2x equals 0.
Okay. So I agree. Put them in standard form, highest power to lowest power. Okay. Well, you should be noticing something. Do they all have an x in common? Yeah. So we're going to factor out a GCF of x. X to the 4th, you divide by x, you have x to the 3rd. Plus x to the 3rd, divide by x, you have x to the 2nd. 2x squared divided by x, 2x. 2x divided by x, plus 2.
Just divide the x out using the 0.
No. Like, in other words, divide both sides by x and make it gone? Nope, because you just got it wrong and missed an answer. Because you're going to lose one of your 4 answers by doing that. Okay? That x, because it's a variable, is a factor. Like over here, You could have divided both sides by 5 because it's just a number and it wouldn't have mattered because it doesn't represent an answer. But if there's a variable, it represents an answer. Okay? Okay. Now what?
That's it.
Definitely not it.
I feel like if people are
Okay.
right about it.
So, the x out front is just going to stay out front. Inside the parentheses, it looks a little different than what we often see, doesn't it?
We have one of our answers. X equals 0.
Okay, we have one answer. I agree. We're just missing the other 3. Now, inside those parentheses, we have 4 terms, yes? And you know this technique. You've seen this technique. You just don't use it very often. Anytime there are 4 terms, my suggestion is going to be that we talk about factoring by grouping. Taking these 4 terms and splitting it in half. Now, factoring by grouping is what we use when we do product of AC. Although back in Algebra 1, factoring by grouping is something you were just taught. Okay? It comes up several times in this homework. So, follow along here, and I'll re-explain it. So first of all, this X out front, guess what? Stays out front. Don't lose it, or you're losing an answer. And then I'm actually going to make this a big bracket. Okay, look at the first 2 terms in the parentheses, x cubed and x squared. What do they have in common? Think GCF.
X squared.
X squared. So we're going to factor out of these 2 a GCF of x squared. When you have x to the third and you divide out x to the second, we're left with x plus x to the second divided by x to the second, 1. Not 0. Something divided by itself is 1. Now, repeat the process for the second half. GCF of 2x plus 2.
2.
2. Is it a positive 2 or a negative 2? Positive 2. So I'm going to write this as a plus 2. And then 2x divided by 2 leaves me with
X.
x. Plus 2 divided by 2 leaves me with 1. I'm in my parentheses. I'm in my big brackets. Equals 0. Okay. We have one more step as we write this in factored form. Now, what's out front?
X.
X. This right here is going to go into 2 parentheses. One of those parentheses is the matching x plus 1s.
Yeah.
Now, here's a reminder. If they don't match, you made a mistake. Okay? So one of your parentheses is the matching x plus 1s. Does it matter which parenthesis? It does not. Your other parenthesis comes from your GCFs. My GCFs were x squared plus 2. And now it's all factored. So we're going to
Set them each equal to 0.
set them each equal to 0. We're in the home stretch.
Still not done though.
The factoring, that was the tough part. Set them each equal to 0. So we're going to set x equal to 0. We're going to set x plus 1 equal to 0. And we're going to set x squared plus 2 equals 0. Okay. What do we know? X equals 0. When it's x plus 1 equals 0, what do we know? Subtract 1 over and x equals negative 1. If it's x squared plus 2, what do I do? In a moment. First, we're going to subtract 2 over. When you subtract 2 over, you have x squared equals negative 2. Once you have x squared equals a number, my job is to square root.
X plus or minus 2y. I square root 2. Yeah, whatever.
Okay? Square root of 2 is square root of 2. Square root of the negative is I. That goes outside. Square root in an equation setting means we put in a plus or minus. Okay, folks, how many answers did I end up with?
3.
We have 0, we have negative 1, and we have plus or minus I times the square root of 2. Did we get our 4 answers we were looking for? We did. It took some work, but we got them. Okay? I definitely saw several problems like this in homework, where it's practicing the factoring by grouping. Okay? It's a skill we need to know. It's just one of those factoring skills that we just don't use as much. Doesn't mean it doesn't exist, and it's not an option. Okay? Okay. Have a little bit of work time. Let's use it. I think, what is it, 10 problem homework maybe? So, something like that. And then if you want me to go back through that previous section, I can.